In this video, I'd like to talk about the math question of the day for Thursday, June 15th, 2023. And with this problem, we need to find all of the solutions to this equation here, which is a rational equation. And rational equations are typically taught in an Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And the general strategy for solving rational equations is to get the variable out of the denominator. Though before we actually proceed with trying to solve this, we should note which x values cannot be solutions here. And essentially, we just need to decide which x values would make our denominator equal to 0. And we can see an x value of 3 would give us division by 0. So x cannot be 3, and that would be true for this part as well. And it looks like -5, if we plug that in here, we would get 0 multiplied by -8, but 0 multiplied by anything is 0. So -5 is also an x value that cannot be a solution. So if we end up with these as our solutions, then we know that they are not actually solutions to the equation. So going back to our strategy, we want to get x out of the denominator here. And let's focus on this right-hand side first. Notice we have this x minus 3. If we were to multiply both sides of the equation by x minus 3, then we can eliminate this denominator. So we can multiply by x minus 3, and let me make this a little bit clearer. I'll multiply on the blackboard here, but we're multiplying by x minus 3, and we'll have to do that on both sides of the equation. So over here, we will also multiply by x minus 3. And by doing that on both sides, notice that our denominator here will cancel with this x minus 3, and likewise, it would cancel here and here. So that will help simplify this problem significantly. However, we still have x plus 5 in our denominator, so we can also multiply both sides of our equation by x plus 5. And at least on the left-hand side, it would cancel out. And on the right-hand side, we would just need to multiply x by this x plus 5. So let's start simplifying everything. Now, what we multiplied by on the left was canceled out with our denominator. So we just have our numerator, and of course we have this negative sign in front. And this negative sign distributes to this entire fraction. So we have the opposite of this quadratic here. So the negative will distribute to all of that. We have minus x squared, minus x, and plus 8. Then on the right-hand side, we distribute the x to x plus 5. We get x squared plus 5x. So we have this quadratic that we need to solve. And when solving quadratics, remember we want to set one side of the equation equal to 0 and then either use the quadratic formula or we can try to factor. So let's move the x's to the right-hand side. We can add x squared to each side and we can add x to each side. And let's also subtract 8 on each side. So on the left-hand side, notice that these all cancel and we just get 0. On the right-hand side, we get 2x squared plus 6x minus 8. And let me just make a little bit of room here so that we can keep working. Now notice that each of these terms is divisible by 2. So we can divide both sides of our equation by 2 just to simplify our numbers so that we get 0 over 2, which is just 0. And on the right-hand side, we get x squared plus 3x minus 4. And we can try to factor this, but if you want, you can just use the quadratic formula. In fact, if factoring doesn't work, that's what we'll have to do. So we know that if factoring works, this will factor into a product of two binomials. Each of these will have two terms. And the first term in each of these would have to be x, since if we multiplied it out, we would get x times x, which is x squared. Now to figure out our constant terms in each of these binomials, we know that they have to multiply to -4 and they have to add to +3. So let's write a list of the factor pairs for -4. We can multiply -4 and 1, or 4 and -1. We could do 2 and -2. Now, they have to add to +3, and that would be this pair right here. So in our binomials, we would have x plus 4 and x minus 1. Now, if you want, you can, of course, re-multiply this out using distribution and prove to yourself that you would get back this quadratic. But at this point, we can actually solve our equation using the zero product property. And for this binomial, if we plug in -4, that would make this 0, and this would be -5, but 0 times by anything is 0. And likewise, for this binomial, if we plug in +1, that would make this 0, and 0 times anything is 0. So these are our two solutions, and what we can see is that they are not in the excluded solutions. So we can go back up to the original problem. We have x is -4 and +1. But to feel completely certain, we do have to check our work. So this part is a little bit tedious, but we need to plug in -4 and 1 into our rational equation, the original equation, to see that we get back something true. So let's make some room, and we can start doing that. Let's start by plugging in x is equal to 1. For the left-hand side in the numerator, we get 1 plus 1 minus 8. And of course, we have that negative sign out front. And 1 plus 1 is 2, minus 8 is -6. And we divide by 1 minus 3, which is -2. And we multiply by 1 plus 5, which is 6. So now let's look at the right-hand side. We would get 1 over 1 minus 2. And 1 minus 3, and 1 minus 3 is -2. So let's see if this simplifies. The negatives in the numerator cancel out, the 6's cancel, and so we get 1 over -2, and both sides are the same, which means that this is a valid solution. So from here, let's check when x is -4. We plug that in. Of course, this is a little bit more complicated because it's a bigger number, but we can still proceed. We have -4 squared, which is 16, and then -4 minus 8, that's our numerator, and in our denominator, we get -4 minus 3, which is -7, and -4 plus 5, which is 1. Now we do the right-hand side. We have -4 over -4 minus 3, which is -7. So let's see if this simplifies now. This is 16 minus 12, which is 4. We still have that negative sign. So we end up with -4 up top and -7 down below. Of course, the negatives cancel. We get 4 sevenths. Just like they would here, they cancel each other, and we get 4 sevenths. Since we got the same thing on both sides, we can feel confident that this is also a valid solution, and therefore, this would be our final answer.